Alright, in this video we want to compute the derivative that we've got right here on the screen, and what I went ahead and did is wrote what we basically need to use, which is from the second fundamental theorem of calculus, the second FTC. And so if we want to use the second fundamental theorem of calculus, it's a pretty straightforward application, only difference being that we can see in the fundamental theorem, the second fundamental theorem, tells us how to integrate just a function of x. And we notice in our problem that we've got x cubed. So if we're thinking of this integral as a function, it is a composite function, right? And then ultimately we can see what we're doing is taking the derivative of a composite function, which implies that we need to think about the chain rule. So let's do this. We're going to call capital F of x this function, the integral from 1 to x cubed of natural log of t with respect to t. And then we're going to do the substitution that u is x cubed. So what we're going to do is look at, right, what we want is the derivative of our function. In other words, what we want is capital F prime. And since this is a composite function, right, where our inside function is now u, we can write that by the chain rule. By the chain rule, we're going to take the derivative of our outside function with respect to u and multiply that by the derivative of the inside function. Right, so ultimately what we're calculating here is the derivative of capital F with respect to x. Right, so let's see. To calculate this guy, what I'm doing is the derivative with respect to u, of my outside function here, so that would be integral, and I'm going to go ahead and put in u instead of x cubed. And then multiplied by the derivative with respect to x of my function u, which is just x cubed. I don't know if this makes any sense. You can make all sorts of substitutions, right, until you're confused and looking cross-eyed, but I think this works. I think this is the appropriate way to write it. Right, so this derivative of u with respect to x is here, derivative with respect to x. Okay, so to compute this derivative, that's a direct application of the second fundamental theorem of calculus, which tells us, right, the function that pops out is the same as the function that's in here. We just get to change the variable that we use. I mean, ultimately, whatever letter you use doesn't really matter. We had a dummy variable t in here. So this derivative, because of the second fundamental theorem, is just the natural log of u. And then this derivative is a basic application of the chain rule, just 3x squared. And of course it's nice to have all of this in terms of x, right? And we know that u was x cubed, so all of that times 3x squared, and might make sense to put the 3x squared in front. Now you could certainly do this without the second fundamental theorem of calculus, or maybe I should say you could verify this just by using the first fundamental theorem of calculus. If we want to just take the derivative with respect to x of this integral, we could attempt to evaluate this integral. We'd have to know the antiderivative of the natural log of t, which you can get if you know how to do integration by parts. I won't go through the integration by parts, but just to show you that we can verify this, we want the derivative with respect to x of, let's see here, we'll use a brace, and we're going to do the antiderivative of natural log of t, which comes out to be negative t plus t natural log t. We're going to evaluate that from 1 to x cubed. Okay, so I'm taking my derivative with respect to x. Alright, so just following the first fundamental theorem, I'm going to plug x cubed in for t. Whoops. I think I need that many. I guess this should be a brace instead of a bracket. So let's see, I'm plugging x cubed in for t. Okay, and then I'm going to plug 1 in for t, so I'm going to have a negative 1 here. And then if I plug 1 into the natural log, I get 0, so this would be just 0. So what does this boil down to? Do the derivative with respect to x of, let's just make these brackets now. So I've got all this stuff with x's and then plus 1. Okay, well when I do the derivative of the constant term, it's going to go away, so I don't have to worry about that. So if we start taking the derivative here is negative 3x squared plus, and then to get the derivative of this term, I have to use the product rule. So let's do first function times the derivative of the second. So the derivative of the second would be 1 over x cubed times the derivative of the inside function, which is 3x squared, plus, and then do second function times the derivative of the first, so that would be 3x squared natural log x cubed. And so what happens here, these x cubes go away, and then I've got negative 3x squared plus 3x squared, so those go away, and I'm left with just 3x squared natural log x cubed, which matches what we found when we applied the second fundamental theorem. And so either way you work it, you should come up with that function.